NASA's New Horizons spacecraft provided humanity with its first close-up images of Pluto, revealing a stunning and unexpected view of the dwarf planet. Before this, Pluto was shrouded in mystery, and no one knew exactly what it looked like. These groundbreaking images were not only exciting but also shocking. Pluto, previously thought to be a lifeless, frozen rock, turned out to be a dynamic, active world, a discovery that has profoundly changed our understanding of this distant planet. For decades, Pluto had been relegated to a mere point of light in the sky, too small and far from Earth for telescopes to capture in detail. The Hubble Space Telescope, despite being one of the best instruments available, could only show Pluto as a fuzzy dot. Other sophisticated telescopes, such as ALMA and the European Extremely Large Telescope, also struggled to get a clear view due to Pluto's small size, its proximity to the Sun, and the darkness of its location at the farthest reaches of the solar system. Scientists had no real idea about its surface, composition, or characteristics until New Horizons arrived. In July 2015, after nearly a decade-long journey, the New Horizons spacecraft finally reached Pluto, and its mission began. Launched in 2006, the probe was specifically designed to study Pluto and its moons, taking the first detailed photographs and measurements. The long voyage paid off handsomely, as New Horizons provided high-resolution images that were a complete revelation to scientists and space enthusiasts alike. The spacecraft was equipped with the latest technology, including a high-resolution camera named LORRI, as well as spectrometers and particle detectors, to capture the most detailed information about Pluto's surface and atmosphere. The journey to Pluto was not only remarkable due to its duration, but also because of the limited time New Horizons had to gather crucial data. Flying at a speed of around 50,000 kilometers per hour, the spacecraft had only a few hours to capture all the images and data before it passed Pluto and continued on to explore its moon, Charon, and other objects in the Kuiper belt. Before New Horizons, scientists thought Pluto was a cold, barren world, a leftover relic of the early solar system. The latest images from New Horizons, however, revealed a planet far more complex and dynamic than anyone had imagined. One of the most striking surprises was the apparent geological activity on Pluto's surface, which suggests that it may be a living, active world. The lack of craters on large parts of Pluto's surface, especially in the Sputnik Planitia region, was a clear indicator of recent geological processes. This suggests that Pluto is not a dead, frozen rock but a planet still undergoing significant transformation. The images sent back by New Horizons were a vivid illustration of this newfound geological complexity. One of the most famous photographs shows massive mountains of water ice, towering up to 3,500 meters high. These icy peaks, reminiscent of the Rocky Mountains on Earth, stretched across Pluto's surface. However, these mountains are thought to be composed of pure water ice, with no rocky components, and their lack of craters suggests that they formed relatively recently in geological terms. This was a major surprise, as it strongly indicated that Pluto has been geologically active much more recently than previously believed. Another remarkable discovery was the Sputnik Planitia, a vast, smooth plain that extends for hundreds of kilometers. This area, made primarily of frozen nitrogen, shows polygonal structures on its surface, which are thought to be the result of convection currents within the ice below. The smooth surface of Sputnik Planitia appears to be constantly renewing itself, a further indication of ongoing internal processes on Pluto. These features suggested that Pluto might have a dynamic internal system, possibly driven by heat emanating from the dwarf planet's core. This heat could be generating an underground ocean, fueling the planet's geological activity and creating conditions for the existence of liquid water beneath the surface. One of the most striking images from the New Horizons mission was the discovery of cryovolcanoes, volcanoes that erupt frozen materials like water, methane, or nitrogen instead of molten rock. These icy volcanoes, which appear as large hills and ridges on the surface, provide further evidence that Pluto is not just a frozen world but a place of ongoing volcanic activity. The presence of cryovolcanism suggests that Pluto's interior is warmer than previously thought, which supports the theory that a liquid ocean may exist beneath its icy crust. This discovery is significant, as it hints at the possibility of life on Pluto, albeit in forms that could survive in the icy depths of an underground ocean. The existence of cryovolcanoes and the surface features they create further emphasize the idea that Pluto's geology is driven by internal heat. This heat could come from several sources, including the decay of radioactive elements within Pluto's interior, as well as tidal forces generated by Pluto's interaction with its largest moon, Charon. Scientists have speculated that Pluto and Charon may actually form a double-planet system, with the two bodies exerting gravitational forces on one another that could contribute to the heat necessary for maintaining a liquid ocean beneath Pluto's icy surface. Perhaps the most iconic image from New Horizons is the famous heart of Pluto, which became a symbol of the mission's success and the planet's surprising nature. The heart-shaped region is made up of two distinct areas: the left side, which is the Sputnik planitia, and the right side, a hilly, more cratered region. This image was not only visually striking but also showed Pluto in a previously unknown and vibrant light, prompting many to reconsider Pluto's status as a planet. This image sparked renewed interest in Pluto and its place in the solar system. While it had been demoted to the status of a dwarf planet in 2006 by the International Astronomical Union, IU, New Horizons findings have challenged that decision. The data collected during the mission showed that Pluto is far more complex and dynamic than a simple rock, and many scientists argue that it should be considered a true planet. Pluto's surprising geological activity, diverse landscapes, and complex atmosphere have convinced many that it deserves a spot back among the solar system's official planets. New Horizons didn't just focus on Pluto itself. It also provided detailed images of Pluto's largest moon, Charon. These images revealed deep trenches and crevices on Charon's surface, suggesting that the moon too has undergone significant geological activity. The discovery of these features was unexpected, as scientists had previously thought of Charon as a relatively inactive body. The evidence of geological processes on Charon further raised questions about the possibility of life in the outer reaches of the solar system. As researchers studied these new images, they began to consider the possibility that both Pluto and Charon could harbor some form of life, although it's unlikely that higher forms of life exist on these distant worlds. The conditions on Pluto and Charon are extremely harsh, with freezing temperatures and little sunlight reaching the surface. However, the discovery of an underground ocean on Pluto raises the intriguing possibility of microbial life, perhaps similar to extremophiles on Earth, that could survive in these ice-covered seas. In addition, Charon's surface features suggest that it may have a subsurface ocean as well, which could be another promising location for future exploration in the search for extraterrestrial life. With both Pluto and Charon showing signs of geological and possibly even biological activity, they are emerging as key targets for future missions in the outer solar system. The idea that Pluto might have an underground ocean is one of the most fascinating discoveries made by New Horizons. Scientists had long assumed that Pluto was a frozen, dead world with no potential for life. However, the discovery of cryovolcanoes, a dynamic surface, and signs of internal heat have led to the hypothesis that a liquid water ocean could exist beneath Pluto's icy crust. This would make Pluto a potential candidate for harboring life, at least in microbial form. Researchers have pointed to several clues that support the idea of an underground ocean. For example, the absence of large craters in the Sputnik planitia region suggests that the surface is relatively young and constantly being renewed by convection currents in the ice. This movement would require heat, which could come from a liquid ocean beneath the surface. The presence of cryovolcanoes further suggests that Pluto's interior is warmer than previously thought, providing another indication that an underground ocean could exist. The discovery of water on Pluto has prompted scientists to expand their search for water in the outer solar system. Over the past few decades, we have discovered that many of the moons of the giant planets, such as Europa, Enceladus, and Titan, also contain subsurface oceans. The discovery of liquid water in these far-flung worlds has revolutionized our understanding of where life might exist beyond Earth. With the possibility of a liquid ocean on Pluto, the dwarf planet has become a prime target for future exploration. NASA's Europa Clipper mission, set to launch in the 2020s, aims to study the underground ocean on Europa, one of Jupiter's moons, which has long been considered a potential site for life. Similarly, the Cassini spacecraft discovered evidence of an underground ocean on Enceladus, one of Saturn's moons, which even emits water fountains into space. These findings, along with the discovery of Pluto's ocean, suggest that water may be more common in the solar system than previously thought. Thank you for joining us on this cosmic journey through the wonders of space. If you enjoyed this exploration, don't forget to hit the like button and share it with fellow space enthusiasts.